Hello researchers, today we will learn how to apply normal distribution test in SPSS. Actually, if we talk about normal distribution, this is a diagnostic test which is required before applying ANOVA test to check whether the model is fit or model is not fit, and to apply the linear regression model or the multi-regression model in SPSS. So we will start from here, that what exactly first of all is the normal distribution. See, these are the properties of the normal distribution, where at such a point the mean, median and mode all are equal. The curve is symmetric at the center around the mean, which is known as the mu. Exactly half of the values of the variables are required to be on the left of the center, and is exactly half the values are to the right of the center. The total area, if we talk about of the normally distribution curve, which is a bell shaped curve, is 1. So this is what we have discussed in those points. This is a bell shaped curve. Okay, so here what exactly we are going to do in the normal distribution in the SPSS, the null hypothesis and the alternative hypothesis. The null hypothesis states that the population is normally distributed against the alternative hypothesis, which is not normally distributed. So all values depends upon the p-values. If the p-value is found to be greater than 0.05, then what we are supposed to do, we shall accept the null hypothesis. And if similarly, if the p-value is found to be less than 0.05, so we could reject the null hypothesis. If we accept the null hypothesis, that means our data, our dependent variable is normally distributed. Okay, and if the p-value is found lower than the 0.05, we reject the null hypothesis. That means our data, our residuals or our variables are not normally distributed. Okay, so what exactly we are going to do in our SPSS tool? In the SPSS, we just open the data sheet, we go in the analyze, we go in the descriptive statistics, and then going to the explore, and we will apply the normal distribution test. So how shall we perform? We will just originally take a look from our actual data sheet in the SPSS. Okay, so we already have opened this data sheet where our data are shown at from 2000 to 2021. That means 22 years data sheet, in which I have taken 3 variables: GDP, inflation and oil prices. And GDP I have taken as a dependent variable. So just quickly take a look how we are going to apply, how we are going to check in our diagnostic data review and analyze whether this GDP as a dependent variable is normally distributed or it is not normally distributed. What if our GDP is found not normally distributed? Then we will transform it into the normally distributed data. So first of all, we will go here and analyze, and we will go here in the descriptive statistics, then explore. Okay, and just press explore, and what we are going to do, first of all, put all the variables here. Okay, dependent list is empty, factor list is empty, label cases y or empty. So we will go here on the plots. In the plots, it is already clicked this normally plots with test. If it is not clicked, then you must click it, normally plots with test. Factor level, dependents together, just ignore, just press none. And if stem and leaf added, just it is up to you whether you want to add or not, but I have not added. And histogram. So normal plots, normality plots as well as histogram, these two are required to be checked. So you just press continue and press which variable you want here, dependent variable. Okay, this is actually, yes, again go there, and continue and press OK. So this is the summary of your normality distribution test is shown here. Data was GDP. Why GDP? Because it was a dependent variable. So there were as many as 22 years data, and starting from 2000 to 2021. Missing values are none, so cumulative frequency is 100%. Okay, so we will descriptive analysis, we are not concerned here. Come to directly our test of normality. So what does this test of normality showing at? Here there are the two methods given, KS method and SW, which is Shapiro-Wilk method. So we are concerned about this here, Kolmogorov, Smirnov statistics we are going to use, which is in short we call it as a KS test. And when we test the same normality distribution in the E views, we apply the jerky Berer test. But here we are not at all bothered about, and we are not concerned about the jerky Berer test. We are concerned about the KS test. Okay, there are two tests as given. Only the one you have to rely on, which is I signify here, known as the KS test. Okay, so KS test, this is statistic, and the significant value, which is actually the p value. Okay, so p value is found to be 0. That means it is far less than 0.05. so what does it mean? Is your null hypothesis is accepted or rejected? So your null hypothesis is here rejected, so that means your data is not normally distributed. So we just put it, and in the histogram also it is showing it it is not showing as a bell-shaped curve, right, isn't it? So what we are going to do, we will apply, then we will convert first of all this non-normally distributed GDP into the normal distributed. So how shall we perform this? We will quickly go to our actual variable view and the data view sheet. This is the data view sheet. So we will go here in the transform, okay, and compute variables. In the compute variables, since I have already applied here, so just remove all such things and start from the scratch. So the new target variable should be given a new name, which is given as NGDP, which will be transformed into the normally distributed. Okay, so here you have to go in the arithmetic, and you will apply the log 10. Press twice, it will give you this. Okay, then come to the GDP and make this GDP available in the log of 10. That means you are going to take the log value of the GDP and then apply OK. So most probably it will show here the new variable is formed, which is known as the NGDP. See, this was the actual variable GDP, which was not normally distributed. We have transformed GDP into NGDP, means normally distributed, because we are going to transform into the normally distributed variable. So NGDP is now formed. We will again take a look whether it is now normally distributed or it is not normally distributed. So we will again go to here, analyze. We will go here again, descriptive statistics, then explore, and then because what new variable we have to take here? NGDP. So where is the NGDP? NGDP is there, so we will put it on the dependent list. How shall we do it? See again, this is NGDP. We will bring this NGDP to the dependent list, and then plots. Everything would remain same. This is none. This is a normality plots with test along with the histogram. Continue, press OK. Then we will quickly take a look whether it is now normally distributed or not. So this is a NGDP. This is a histogram, which is showing here, yes, like this looks like the bell-shaped curve, and test of normality. Now see the same Kolmogorov test, which is now showing at 0.082, which is greater than, okay, you must consider here, this is a significance, the significance value, okay, which is showing here like, okay, you are concerned with this value. This is actually the p value. This is what? P value, and we find this p value is greater than 0.05. If it is greater than 0.05, whenever the probability value, p value is found to be more than 0.05, then your null hypothesis is accepted. And what was your null hypothesis, by the way? Your null hypothesis was that GDP is normally distributed. So it was previously not found normally distributed, and you have transformed into the normally distributed data like here. Okay, it was not there, but in that case it is more than 0.05 after converting into the normally distributed data, and we have named it now NGDP. So this we have converted. Now the thing is, why I have already explained that why we are concerned about the normality distribution and bell-shaped curve and all that, because we are concerned whether our model is fit or not. So the fitness of the model will be ascertained from the ANOVA, analysis of variance. So before applying analysis of variance like ANOVA test, or before applying either the linear regression or multiple regression, it is mandatory. Most of the researchers nowadays, they have not been doing this, but this is a wrong way, and you must try to check whether your data is accurate or not. Accuracy is one of the most vital elements of your statistics. So you must apply, because it doesn't take much time. So you just diagnose the data and remove it from all the morbidities, like data is not normally distributed, or data is not found to be stationary. So before applying either the linear regression model or the multiple regression model, it is recommended to check your dependent variable at least should be normally distributed or not.